let's take a quick look at displaying point cloud data in ProRaster. I'm using ProRaster Scientific today, but the same applies to all levels of ProRaster, so ProRaster Essential, Premium, and Scientific. So you will need to have your points in an MRP format file. So you'll use the point processing options in ProRaster Scientific to import LiDAR data or to import general multi-banded point data into your MRP file, and then you can display your MRP files in a ProRaster algorithm. In this sense, it's just like rasters, so you can create a raster source that contains multiple MRP files if you want to display multiple MRP files at once, and you can manipulate them through the same mechanisms. So if I go Open, New Algorithm, and choose Recent Point Clouds, I'll choose this MRP file that I just recently created. So it gets displayed using a point lookup table color layer in an algorithm. So as we zoom in and out, you'll see that the collection of points that are being displayed changes because you're accessing data from different levels in the overview pyramid. So firstly, we can control the resolution of those points on screen. So if I go to the color component, you'll see that on the component tab, there's this adjust resolution option. So if I adjust it up, the density of points will decrease on screen. If I adjust it down, the density will increase on screen. Of course, the higher the density of the points, the more work the system is doing to render those points. So that allows you to adjust the density of the points that you're displaying on screen. Secondly, in a map, if we just come in here, we can display a tooltip. So I'll go key data value for tooltip. And as you move over the points, it'll tell you the coordinate of the point. And in the case of LiDAR data, it gives you the classification label for that point. You can also right-click and choose Tooltip Key plus All Data Table. Now as I move around, you can see that the data is being presented in this spreadsheet in ProRaster itself. So you've got all the bands available for each point that you select and all those data, all that data reflected. And just a little tip, if I'm looking at, say, this point, and then I want to move over and look at my spreadsheet, just hit the Shift key and hold that down, and then you can move your cursor off of the window without triggering any other points, and then you can display the values of that point in the spreadsheet. So let's just look at color modulation. So we'll click on the color component, and you can and this is the MRP file that we've selected, and then you can choose any one of these bands. So by default, we're color modulating by the X coordinate, Y. There's the Z coordinate. With LiDAR data, you'll usually choose the classification band, and for LiDAR data, we supply some special LiDAR classification color tables, which you can use to display your LiDAR data in a reasonable color lookup table format. So, for example, all these brown points are ground returns, and green points are vegetation returns, and so forth. The actual points themselves have some display properties as well. So if you click on the layer in the tree, you'll see that there's a points tab out here on the right. So firstly, we have point size. So if I zoom in a bit so that we can see this, points by default are just little round dots. If I go up to a point size of 12, you can see that they're, or even larger, you can see that they're big round dots. So you can control your point size. You can override the point color if you just want a constant color, and also override the opacity. So you can bring the opacity of those points right down if you want. And if you have LiDAR data, then you can apply a less query to those points. So for example, I can choose just the ground points, and now only those brown ground points are displayed for that whole data set. The last queries are edited via this last query editor. So there are a bunch of standard last queries, and then you can add in your own last queries using all sorts of rules and so forth to select the points, or to select the returns that you want from the pulses. So on the color component page, you can choose your band. You can specify the coordinate system if that's not known. You can do data conditioning. All the color modulation options are the same as for raster data. So let's look at some of these other layers. So firstly, opacity. So let me come back up here, and we'll take this last return query out. Opacity, so this is an opacity modulation option. You can only modulate by the same point file that you're already rendering. So you can see that these selections are all disabled. All you can do is select the band. So let's modulate by the Z band, for example, the height. Come in here and set a, say, equal area transform. So now you can see that points that have a higher Z value are more opaque, and points that have a lower Z value are more transparent. Just like the opacity modulation in a raster. There's also a clipping component, and this one is quite complicated because it works in 3 different ways. Firstly, you can select the point data file that you're working with. Then you can select a band, and then you can use a data conditioning filter to filter out data that you don't want. So for example, I have this clip, the Z value between 0 and 10. So this is going to filter out everything that doesn't have a Z value of an elevation, a DM, between 0 and 10. So if I enable that, all of the points that have within 0 to 10 are retained, and everything else is clipped out. So that's one way that you can clip. The second way that you can clip is that you can browse for a raster and select a normal raster, and then that's exactly the same as your normal clipping or masking. Wherever the raster has valid cells, then points will be displayed. Wherever they're invalid cells, points will not be displayed. So that's clipping by raster. And then thirdly, you can clip by polygon. So let me demonstrate that quickly. We'll just draw a polygon. I'm going to use the area tool, and I'll just draw a little polygon, then right click again, and then save that polygon via the area tool. And that goes into, say, there, demo polygon, yes, save it. And then I can go clip by polygon and select that polygon. And you can see that the points are clipped to the boundary of that polygon that I just drew. So that's the clipping layer. There's a second kind of layer, and that's a point RGB color layer. I'll just show you how that works. It's exactly the same, except it uses red, green, blue color modulation rather than lookup table color modulation. So I'll go into the red component, select my point raster, and then I'm going to choose the red band, the green band, and the blue band, and I'll just turn off that other layer. And so now you see that we're getting red, green, blue color modulation. Often good idea to increase the size of your points so that it fills in, and you can see that we're getting the reflection of the aerial photography in that LiDAR data there, vegetation over here, and some kind of village here with these houses. So that's just like a raster. Again, you can go in and change the data transformation for each of your red, green, and blue channels. In LiDAR data, you have red, green, and blue, assuming that they have actually been recorded in your LAS files. And there's also a near infrared, which might contain data as well, depending on what kind of surveys you've been doing. So you can select from those sorts of bands. So that's how to display point cloud data that's in an MRP file in ProRaster Scientific, Premium, and Essential.